I'm going to change my settings so that you can see this. Okay. I think we can go ahead and get started as people start rolling in. Hello, welcome to the last of our Dev Day replay webinars. Just to let you guys know what's going on here in case you haven't been to the first two, although I do think that the people I'm seeing here have. We did a developer's day at SIGGRAPH with a full day of courses on developing with Shotgun. And we decided to replay those courses as webinars, and we're going to record those so that people can have them available to them for the future for people who weren't there. Today's is Advanced Shotgun Development, as you can see on the screen. Thank you, Manne. We're going to have three presenters today. First, Manne is going to talk about cloud configuration and also revision control with your pipeline configurations. Jeff is going to go through writing a custom app. He's actually going to go through the process of writing an app with you guys, which is awesome. And then Rob is going to talk about integrating Shotgun with Forge, which is Autodesk's cloud API. So that one's kind of cool and quick and fun and interesting too. I'll mention quickly that as far as like our existing webinar cadence that we had before this, we've been doing bi-monthly webinars. The plan, there's not a lot of people here, so this isn't maybe the biggest, well, you guys will get the first news of it. I'll say that. The plan is to move that to a monthly cadence just because we found that the interest in these Dev Day courses at SIGGRAPH was so much, like so many people showed up and were so enthused about the whole process that we think that we want to talk to you guys more. There's a lot to talk about when it comes to Toolkit and ecosystem. It's all complex, interesting, cool stuff. So I will follow up on the Shotgun Dev list with a thread about potential topics that you guys want to talk about. And then we'll start scheduling those in and you'll have the opportunity to see even more of us, which it's exciting for us. I hope it's exciting for you as well. Okay, I will hand it off now to Manne to kick us off.
Sweet, thank you. Yeah, so welcome everyone, and like Tana said, we'll be recording this as well. So if you guys want to go back and check it out again and replay it, it's going to be available soon. So this is all about advanced shotgun development today. Oops, let me get my stuff in order here. So there'll be three of us, like Tanas was saying. I will start to talk about deployment, cloud-based configs, in particular, how to deploy to remote users. Jeff will be doing Toolkit app stuff, and Rob will be showing Autodesk Forge. So we have like around about half an hour each. Quick introduction about myself, pipeline and Toolkit enthusiast. I've been doing pipelines and tools for VFX, animation, and games for the past 15 years or so. And I kicked off the Toolkit project around 5 years ago. So it's cool to see that we're doing these webinars now. It's very exciting. It's cool to democratize pipeline for a wider audience. So for the next 30 minutes, I'll be talking about remote deployment and what we now call distributed configs. So we're going to be talking a lot about how you can set up Toolkit cloud-based configs for a remote user base, and we'll be going through some of the kind of traditional setups of Toolkit projects, and then we'll show how that's different from these new configs. So this session is all about these distributed configs. So before we start, let's talk a little bit about the background and the motivation. Why are these configs important, and what does it mean that they are distributed? So traditionally, a lot of studio setups were in a single geographical location, and artists would just access a large shared network storage where files and data would be kept, and everyone would see the same thing. And this is what Toolkit was originally designed for, and what we today call a centralized configuration. And it would look something like this. You would use the Shotgun desktop setup wizard A TD would select the config, choose a folder on the shared storage, where to put it, and then as part of the wizard, it would download, make sure that all the required dependencies and tools and apps would be downloaded as part of the process, and then it would be available to all the artists in that location. And while that still is very much a relevant workflow that a lot of people are using, VFX studios today are shifting to this more sort of complex topology where a lot of them spawn multiple geos. And in addition, it's also common to have remote workers and outsource vendors that you want to exchange data with. And this is where the kind of the motivation for Toolkit distributed configs come from and where they come into play. So distributed configs don't need to be installed in a central storage. Instead, they're downloaded from Shotgun and they're installed on the fly. So this means that anyone who can access the Shotgun site can also access the Toolkit pipeline. So distributed configurations are useful for many different reasons, and they can be used in lots of different ways. So this session is all about that. I will show you a bunch of hands-on examples how you can work with these setups. So I will show you how to set up a distributed config. I'll show you how to make updates and changes to it, and how to push those changes out to production. We'll talk about how and why source control is a really good fit with these distributed configs, and why it's a good idea in general. And lastly, I'll touch on what sort of lies beyond these sort of first 30-minute introduction that we do right now. So to kick this off, let's take a really quick look at something that you probably are familiar with, which is what happens with Shotgun Desktop and Toolkit if you don't configure it at all. So here's starting up my video, basically just launching Shotgun Desktop and logging into my site. And Shotgun Desktop starts up, and you see the UI, you see a list of your projects. You jump into a project, you see it sort of spinning, it's loading, and now you have a list of your launchers and your Toolkit apps. And from here, I can launch Maya, Nuke, as you know, other applications, and they will have Toolkit apps available there as well. So let's dissect this. What actually happened in desktop? Well, behind the scenes, when Shotgun Desktop starts up, it has built-in logic to connect to the Toolkit App Store and download the latest basic configuration, that's tk-config basic, directly into a cache folder on the user's machine. And once it's downloaded it, it will download all the dependent apps and engines and all the stuff that's been defined in that configuration automatically, and things will begin to start up. You don't need to do any project setup here. Everything happens on the fly, and it works for any user anywhere. So this default behavior that's built into Toolkit is the simplest example of how a distributed configuration works. So a configuration, all its dependencies are downloaded from the cloud to a user machine on the fly. So we were thinking, having built this and released it, hang on, what if we could utilize the same logic for the pipeline configuration for an actual project? So basically, instead of having the Shotgun Desktop download your default configuration automatically from the App Store, we could set things up so that our artists would be pulling down a config of our choosing from our own Shotgun site instead. And this is basically the idea. So let's take a look at how a distributed Shotgun project can be set up. This is all done via the project setup wizard as well. And we are adding some new features right now. So I'll be showing some new stuff to help with these workflows. So let's take that project we had that we just jumped into and make it our own by going into the advanced project setup and launch the wizard. So this is familiar, just the usual steps of this sort of wizard where you choose your configuration, you go through, you assign storages, and you select your project name and where you want your data to go. And then you get to this page. So here we've made some changes. So we've updated the UI to handle distributed setups. So if you go with a centralized setup, this is the classic way things have always been set up. It gets installed in the location of your choosing here, you put in the parts. However, if you select the distributed setup, the configuration will instead be uploaded to Shotgun. So let's do that. I'm going to select the distributed setup, and here behind the scenes, the configuration is zipped up and uploaded to that pipeline configuration that is created in Shotgun. It's a really lightweight, it's a quick process, it's not a big file. And once the wizard finishes, I jump out to the project. It kind of restarts the project. Here it will go in, download that configuration again from Shotgun, check that all the apps and engines and everything that's defined in it is cached locally, and spin that all up. So now I'm looking at my first distributed configuration. So what just happened? Well, basically the config wizard that we ran uploaded that zip file to our Shotgun site. The artist then launches Shotgun Desktop and logs in. And at startup, the desktop application downloads that configuration from Shotgun. So the configuration is analyzed, like I was saying. Dependencies are pulled down all to your local machine. And then from there on, you can then launch Maya, you can launch Nuke, etc. And this pattern means that users anywhere can get the pipeline tools delivered from Shotgun. If you can log into Shotgun, you'll be able to get the tools to your machine. And if the config in Shotgun changes, the machine, they will automatically detect this and update. So please note, however, that this is just the tools in the pipeline that's coming from Shotgun. We are not handling remote file transfers yet as part of this. This is just distribution of apps and pipeline tools. So if you have remote artists, you'll have to transfer the file separately. This can be scripted, for example, by reading published files out of Shotgun or and using that to drive file transfers. And like you saw in the earlier example, we just picked the default config. So a distributed config can have templates, can have storages assigned, and it just works like a normal config. Another benefit is that if your shared storage is optimized for large files, especially if it's a Windows storage, it may not be great to install Toolkit on, because Toolkit is lots of small Python files. And in that case, a distributed config can improve your performance, even if you have a shared infrastructure that all users are using. So let's take a look at what happened in Shotgun as we were running through the setup. What did the process actually do? Because it's pretty simple, and you can do this manually if you want. So it just created, for my project, a primary pipeline configuration. It set this plugin IDs field, and it basically uploaded a zip file to this uploaded config field. This is something that was added in Shotgun 7.11. And basically, these are all the steps. So it's not doing something fancy. It's something that you could do manually. It's just trying to provide a simple workflow so you don't need to remember all these things. And we can upload this, we can download this zip file and unpack it and see that there is nothing magical going on here. It's basically just a Toolkit configuration. So I could just grab one of these from GitHub, for example, and upload it to Shotgun, and that would work too. So that's all it really takes to set up your distributed config. So to summarize, this workflow makes it easy to push tools to any artist anywhere. And pushing updates, it's just a matter of uploading a new zip to Shotgun. Artists will then download that automatically and get that when they restart their tools. And you can still use Shotgun's local storages and template system for all of this stuff. All apps, engines, and frameworks needed to run are automatically cached on the user's machine. And please note that this is not like a file transfer mechanism, but it deploys your entire tool chain to people remotely. So having a zip config is great, but it's kind of locked down. Now everything is in Shotgun. So how do we edit it? How do we tweak it interactively? How do we, as developers, go in and make changes and try things out? Where does it live on disk? And if it's downloaded every time on the fly? Is there a tank command? So all of these questions we sometimes get. And in this section, I will now go in and say, what does a change cycle look like? How do we actually make changes? So all these new distributed setups will come with some new tools. So we have on the context menu, you can choose to create a new config sandbox. And this is a convenience app similar to the clone configuration that we have for centralized configurations. So I can just basically say, hey, I want to start work on this. So just on my disk, create a folder, and I'll pick a folder. You can see there's a checkbox to copy the configuration into that folder. And very quickly, this convenience tool downloads the config into that location on disk. And if I leave my project, I go out, I go back in again, and I reload, essentially. You can see that on the menu now, I now have, in addition to my kind of production, my primary config, I now have Manne's config sandbox. So I can jump into this, and you see I get that blue banner to say, hey, this is like dev mode. And now I am not looking at that zip file, that remote zip file anymore, but I'm actually looking at the config that is on my local disk that I just created. And now I can begin to make config tweaks, hook changes, app development. So let's flip back to Shotgun again to see what happened as I was running that tool. So a new pipeline configuration has been created in Shotgun. And there's two things here that are kind of worth pointing out. It's restricted to my user only. So no one else will have this in the Shotgun desktop on that drop-down menu. It will just be me or anyone else who is in that user restrictions list. So that's great, not to confuse any artist or anyone else. And instead of using an uploaded config, you can see that this is actually using what we call a descriptor URI that is pointing to that path on my local disk. Which of course means that anyone who I invite in that user restrictions list will have to be able to see this path in order to actually access that stuff. So, and this whole URI, descriptor URI, is a flexible, quite technical system that we use to describe remote locations. So we have, if you're interested, go check it out in our API docs. There are lots of ways to effectively point to remote locations. They could be on disk, they could be in GitHub, in the App Store. So this is a way to do that, but that's beyond the scope of this introduction talk. So once we're inside of our config sandbox, we have a couple of new options. So you can see I can easily jump to my config sandbox, and that just basically opens Finder or your file browser in that location where you do your work. So now I can jump directly here. I can start making changes, making tweaks. And inside of Maya, inside of Nuke, I have the whole reload and restart button I can just run, and that will pick up the changes. So this is great for dev. Another common task is to be able to see if I have a config, to see if there's been any updates in the App Store. Am I running the latest versions? So we've added an option to do that from Shotgun Desktop as well. And you can see it's effectively just running that tank updates command, but inside of a window with prompts, you can press yes, no, as you're being presented with the updates. But it's effectively just wrapping that same user experience that you get if you have a centralized config and you're running tank updates in a console. So to recap, we started here with our Shotgun project. We used the setup wizard to grab the default config from the Toolkit App Store, and we uploaded it to Shotgun. We then created a config sandbox on our local disk and copied the configuration across so we can now edit it. And we ran our updates, we got some new stuff. So next step is to basically take our changes and push them back and deploy them into production. And this is super easy. So I'm just gonna grab that dev sandbox I have. I'm gonna just zip that up. Now I have my zip file. And I'm going to go into Shotgun, and I'm going to go replace with uploaded file, and I'm just going to upload that zip file I have there. And now the moment that reaches Shotgun, if you restart desktop, you will get those changes. So now all of my remote users will be getting my latest version of the config. So this is great. However, these kinds of workflows tend to be hard to maintain. Sometimes things go wrong. You need to figure out what's changed and why, or you have multiple people working together. So this is all about source control. I'm sure you guys are familiar with that. And this section of the talk is about how you can use source control in conjunction with these cloud-based config, distributed config workflows. These workflows have no preference on what source control system you use. It can be anything. It's all just something that has a concept of branches and tags and kind of, the stuff source control is doing. We'll be using GitHub because all of the Toolkit configs, apps, engines, etc. are already in GitHub, so that's convenient, but it's not restricted to just GitHub. So imagine there is a studio configuration Git repository where you're basically tracking, here's the configuration that we run our projects with in our studio. You have a sort of a timeline here, and you create tags, and whenever you have a tag, you create a zip file and you upload that to Shotgun and you deploy that. That's your pipeline deployment, like we just saw before. And sometimes you tag something, you update all your projects, just upload lots of zip files. Sometimes you deploy one project, depending on what you want to do, depending on the state of your project. When you want to do work, you create a branch, a work branch, and you can then basically set up one of those config sandboxes. And there is an option in that tool that I just showed that basically creates an empty sandbox that doesn't copy the configuration that you're running into the sandbox. And then if you create an empty one, if you untick that checkbox, you can then just clone your Git configuration and check out your work branch in there. And once you're done, you can push it back to Git, create a pull request, get it code reviewed, and then once that's been merged in, you can then upload that tag that you've tagged up for your new release into Shotgun. So this, and with something like GitHub, these standard workflows, it's super simple to track change. You can easily see what's happened. You can diff your changes. You can do comments. You can see all sorts of things. You can look at the commit history. I'm sure you guys are familiar with these types of views, but it's pretty quick, and very quickly you get a lot of control, and not just for code, but also for the pipeline itself. You can see what's changed. You can see the conversation around changes. You can see what things went into each release. And GitHub in particular is great. Each tag you get automatically a zip file for your source code. And you can basically grab one of these zip files right out of GitHub and upload that to Shotgun, to the uploaded config field. So the deployment is very, very lightweight and straightforward. So I've shown you some of the basic tools and kind of dev cycle around distributed configs. We've seen how you set up a new project with it. We've looked at some of like what's happening under the hood. We've looked at the dev cycle. We've looked at source control and how you can kind of, by using a source control workflow, you can be a lot more organized. And as you're pushing these updates to Shotgun, you also version them, and source control is handling that. But that creates a more organized setup. So now we're going to dive into a bunch of more specific features and patterns that we have added over the past year as we've been trying to help people get up and running with these kinds of setups. So one cool thing that's possible to do with distributed configs that are not possible with classic configs is to set up a site level. So if you create a pipeline configuration in Shotgun and you don't assign a project to it in the project field, it becomes a site-wide configuration. That means that every project you create will automatically pick this up. So there's no need to use the project setup wizard. They automatically have a config that they will pick up. And if you do have a project C, that you, for some reason, you want to have another config, you can either just run the project setup wizard, or you just basically create a pipeline configuration manually for that project and upload and have the project assigned to that pipeline configuration and upload a config. And that will basically kind of override and take precedence. So this is an easy way to kind of have a studio config that you maintain, that every project gets updated except for the ones where you want to override something. And when Toolkit downloads and caches stuff as part of the startup process, it puts that in what we call a local bundle cache folder. You can see the parts there. However, if you have clusters of users, it may not make sense that every single user is downloading the same thing. So in this case, you can set up caches that are shared to avoid redundant downloads between machines. So this is another, This is another advanced topic. So there is an environment variable that you basically can set up that controls where Toolkit will go and look for these cache locations, which makes it easy if you have shared storage to set that up. And not every facility has access to the internet. So this is the sort of third advanced pattern. Usually this is because of security restrictions. There are also ways to actually distribute these configurations so that they are fully self-contained. So in this case, if you want to, if your site and your users don't have access to the internet, you can start with a configuration, but instead of uploading it to Shotgun, you can create a build process that basically looks at the configuration, analyzes it, downloads all the dependencies, and puts them into a bundle cache folder inside of the configuration itself. So we're basically just downloading and kind of baking in all of the dependencies, all the versions of the apps and engines that the config contains. We can then zip that up. It's going to be a bigger zip file, and we upload that to Shotgun. And then when a user is running Shotgun Desktop, it will basically download that self-contained bundle from Shotgun, but that contains all of the dependencies you need. So it doesn't need to reach out to the App Store or to anywhere else to actually run the pipeline. And so all the user needs is a connection to the Shotgun site. It doesn't need a connection to the internet or any other kind of external place. And then once you have the config downloaded by, say, desktop, you can run Maya, you can run Nuke just the same way. And fourth advanced pattern is around remote compute and render farms. So we've looked at this from the kind of the outside, Shotgun Desktop, Maya, all the DCCs. They're kind of managing these distributed setups under the hood. We've distributed code that just handles this so that it automatically pulls stuff down from Shotgun and checks for updates and stuff. But this is all actually handled by an API that we call the Bootstrap API or the Toolkit Manager, which is super straightforward to use. So you can, for example, create your own Python script that you can run on a render farm that pulls down the latest config from your Shotgun site, gets the dependencies, and starts up tools or automation running on the render farm. And just a super quick example from our dev docs, that essentially most of this is comments, but you have 4 lines of code there, 5 lines of code that basically kicks off one of these Toolkit managers, points it to the configuration you want it to run and to find, and then the bottom line there is like Bootstrap engine, which kicks off the engine. That could be the shell engine or the Maya engine if you want to run Maya batch. But basically, it's very straightforward to sort of start all this stuff up, even in custom scripts. So in general, I also recommend checking out our developer docs. They contain a bunch of detailed information about distributed configs. And of course, if you have questions, just reach out to us as well. We're super interested to explore these patterns. In fact, we at SIGGRAPH this year at DigiPro, we published a paper on a number of different patterns that we've seen in the industry around cloud-based distributions. So if you're interested to kind of really geek out, check that out. Yeah, there's a bunch of further reading in our GitHub repo. So you can, yeah, there's a QR code to snap if you guys want to do that. There's also all the slides will be in that GitHub repo as well, along with some links and the stuff I've mentioned in this talk. So, Tanas, I don't know, are we doing questions right now, or are we doing that at the end of the webinar?
We can take questions if there are any. In the past, there haven't been that many, so it hasn't been an issue. At the moment, there are none, but if anyone wants to put them into the Q&A box right now, feel free, or we'll go on. Doesn't look like there's anything.
Sweet. Okay, well, great. Thanks for listening. And I am going to pass it to Jeff now, who's going to do an awesome Toolkit app tutorial. Thanks, guys.
Alrighty, let me get my screen share set up and we will get going. Apologies, 1 second. I can't see my mouse cursor. Woo. Stand by. All right, one more time. Now I can actually see my screen. All right. We're going to be talking about writing your own Toolkit app, and this is going to require us to actually look at some code now. Everything we'll look at will be Python and YAML, which if you're Toolkit users, you'll be intimately familiar with. It'll all be very, very simple. What my goal is here is to show you that it's entirely possible to write a simple and very immediately useful app for production in a very small amount of code, making use of some things that we provide out of the box. So without further ado, a little bit about me. I'm Jeff. I work with the Toolkit team, have for the last 3 years, a little more than 3 years now. Before that, I spent a lot of years as a pipeline TD at Rhythm and Hughes and Blur. And most recently, I've been working on Toolkit and the Shotgun ecosystem in general. So let's take a look at the app. There's a little bit of a story that goes with it that I'll explain. In this case, we have an artist who has found a bug in Maya. And what they want to do is they want to report that bug to their support team so that maybe they can take care of it. And so what they do is they launch this, this bug reporter app that I have written. They've attached a CC list to it so that the right people see it when the ticket goes in. They give it a little bit of information about what's going on and what they're seeing on their end. This is sped up like 200%, but I'm still a slow typer. So they take a screenshot to attach to the ticket and they submit that ticket to Shotgun. After they do that, the support TD who was CC'd on the ticket gets an email notifying them with a new ticket that they're CC'd on. They can go into Shotgun, they can assign themselves to that ticket. They can set the status to in progress, and they can give the artist a little bit of a quick reply to let them know that they're taking a look at what might be going on and that they'll have it fixed as soon as they possibly can. So that's our app from a functionality standpoint. And what we're going to do is we're going to break this down into 3 primary sections. The first thing we're going to do is we're going to take a look at the structure of a Toolkit app, just from a high level, not necessarily diving into the code, but just the components that make up that app bundle. We're going to take a look at using Toolkit frameworks, some out-of-the-box components that we provide that you can use to quickly put together an app with some fairly complex features without having to write a lot of code. And then we'll take a look at actually developing this app, writing code. This is where we're going to take a look at actual Python code so that you can see how I've put this together. And hopefully you'll be pleasantly surprised by how little code I had to write to get to this, to these features. Like Manne said, we have Dev Day 2018 GitHub repo that's public. The QR code is the same as what Manne put up. It's going to contain a bunch of stuff. Most importantly for this presentation is that it does contain all of the code that I've written here. So the app that I've written, you can actually pull it out of this GitHub repo, plug it into your configuration, and launch it and do exactly what you just saw that video show. Stepping forward, like I said, we're going to take a look at the structure of the Toolkit app first, and that really breaks down into 3 primary components. The first is the app.py. This is a public interface for the app. It fulfills the contract that all Toolkit apps must fulfill in order for Toolkit to load them, initialize them, and present them to the user instead of the Shotgun menu. The second is the info.yaml file. Every Toolkit bundle comes with an info.yaml, and this describes the configuration for the app. And last, and certainly not least, is the Python module that is bundled with the app, which contains the business logic. That's where we actually write the code to make the Qt dialog do what we want it to do. Taking a look at the contents of the app.py, we're not going to go into a lot of detail on the actual code here, but just to give you a high-level breakdown, We've defined a class for the app. We're subclassing from the application-based class that's provided by sgtk.platform that comes with TK Core. That's the base class for all applications, all Toolkit apps that we've written and that you will write. And second, sort of the bare minimum case of needing an init app method, which takes care of some initialization work when Toolkit is bootstrapped, the engine's getting started up, your app is being loaded. This describes the behavior. In this case, we're setting up our menu command, and we'll look at that in a little more detail later on. Next, the info.yaml, I said that this contained configuration information. This is not the entire contents of an info.yaml. If you open one up right now, you'll see more than this. These are the important bits that we're going to go over in a bit of detail. The first are the configuration settings. In this case, what I have is a CC setting, which allows me to specify a comma-separated list of usernames in Shotgun that will act as the default list of users CC'd when the user launches the app. Second is some user-facing information, basically pretty print information for the app, including the display name, the name of the app that the user will see, and anything that we have that shows the name of the app, and then a basic one-line description of what the app is responsible for and what kind of features that it provides. This is important to be worded in a way that users, in most of our cases, artists, are going to be comfortable with the messaging and the names that you use. And third, and something we'll go into a lot more detail as we continue the presentation, are the required frameworks for the app. This tells Toolkit that when the app is initialized, it needs access to the specific framework in order to function. The third component that we're going to talk about is the Python module. I said last but not least, certainly not least, because this is where the business logic, where the actual features are implemented for the app. And there are a few pieces of this that we need to take a look at because we're going to look at them in detail as we move forward. The first is the app module that's bundled up inside of this Python subdirectory within the TK Multi-Bug Reporter apps bundle. This is a Python module like any other. You see that there are init.py files. There's a submodule, which is what we're going to take a look at next. The UI submodule contains the layout for the UI. This is something that I built in Qt Designer and generated from the build resources shell script that we'll talk about in the future. And then lastly, the dialog.py, which is where I've actually implemented functionality that I've added to the app. This is where I wrote Python code from scratch. Which leads us to using frameworks. And we can't really talk about frameworks unless I show you the demo app. TK Multi Demo is an app that we provide that offers a lot of demonstration code for the components that we provide from our frameworks out of the box, including the code that was written to actually implement those demos. So it's a good place to copy paste. Really importantly to this presentation, and something that I think is useful to everybody, are the Shotgun Fields widgets, which is what you're seeing right here. It's a way to take an entity and represent all of the fields on that entity as Qt widgets, complete with functionality around things like searching for setting a project in this case. It's an incredibly useful component that we provide in our Qt widgets framework, and it's something that we're going to use in this app that I've written for the CC field. So if you haven't taken a look at the demo app, it's public repo, just like everything in Toolkit. It's a TK Multi Demo. You can plug it into your configuration right now and take a look at it. Secondly, we also are going to be looking closely at TK Framework Qt widgets. That contains the Shotgun Fields widgets and the screen capture widget that we use in this bug reporter app. So you can take a look at that if you haven't already. And as Manny mentioned, we have developer documentation for all of this stuff. And if you take a look at the developer documentation for the Qt widgets framework, in this case, what I have highlighted are the Shotgun Fields widgets. There's a lot of really useful information that will help you get started with making use of those components that we provide. Going back to the info.yaml file, I had mentioned that we had a list of required frameworks. Looking at that in a little more detail, this breaks down into 3 component pieces within that required framework. The name of the framework that we're interested in, which is pretty straightforward, TK Framework Qt Widgets. And then we have 2 different methods of specifying what version of the framework is okay for this app to use. The first is the major version that we want to specify. If you look at the version setting here, we're asking for version 2.x.x, and what that means is we require the use of the major version 2 of the framework, and we're fine with using any minor or patch version underneath that, except that what we're needing to use requires a minimum version of 2.7.0. What the version setting allows us to do is insulate ourselves from backwards compatibility breaking changes in the framework. If there was a major version 3 of the framework, we wouldn't be able to guarantee that apps that were written that made use of version 2 of that framework would continue to work. So what you're doing is you're specifying the major version that you wrote the app with, and that will ensure that you're not hit by backwards compatibility issues later on if we release a version 3. Specifying the minimum version in this case, or in cases that you might run into this, we're constantly adding components to these frameworks that don't necessarily break backwards compatibility with existing apps, so they don't warrant bumping up to, in this case, a version 3 of the Qt widgets framework. But if you're making use of a widget that was added in version 2.7.0, then you need to know that you're going to get at least version 2.7.0. So it's not really protecting you from backwards compatibility issues. What it's doing is it's ensuring that if the component you are using out of the framework was added, in this case in 2.7.0, that you need at least that version in order to function properly. And if we take a look at a little bit of Python code, importing from frameworks requires the use of the import framework method that is exposed by the sgtk.platform module. And what you can see is that you specify the name of the framework that you're importing from and the name of the component that you want to pull out of there. And that maps, if you look inside of the Qt widgets frameworks Git repository, you'll see that under the Python submodule, there's a whole list of submodules in there that contain the individual components. In this case, we're using screen grab and shotgun fields. And we'll look in more detail at actually making use of this code after it's imported in the next section, which is developing and configuring the app. So the first thing we want to take a look at is the starter app, and we provide the starter app as a good place. It lays out a lot of the basic framework of an app that you need, and then what you can use is you can use that as your starting point. And it keeps you from having to write a lot of busy logic. You'll see that there's the Python module set up with the app submodule. You have a dialog.py that implements some basic stuff. You can then take the template layout that we provide, tinker with it in Qt Designer, implement the logic in dialog.py to make that user interface that you built in Qt Designer do something interesting, and you have an app. And the starter app is incredibly important. I've never written a Toolkit app that didn't start with the starter app, and I wouldn't suggest anyone do otherwise. The starter app is a really great place to start. It gives you everything you need. We keep it up to date. If there are changes in the platform, we'll make sure that we update the starter app to reflect those changes. In addition, there's a README in there that gives you some basic steps to get you started with. I mentioned that I use Qt Designer, and what I do there is I construct a basic layout in a drag and drop fashion. You certainly don't have to if you don't want to use Qt Designer. If you're more interested in coding your layout straight ahead in Python, you can do that. I find Qt Designer to be easier, especially since dialog resize behavior can be a little tricky to work out when you're writing layout code. Straight ahead in Python, if you're doing it in Qt Designer, you have a nice visual way to drag the window around and resize it and see how it's going to behave before you actually get into code. So my recommendation is to use Qt Designer, though you can choose to or not, depending on your personal preferences. Something important that if you are using Qt Designer is to make sure that you name your widgets and layouts identifiably, because we're going to be making use of those when we're writing code, and for maintainability and just your own sanity and the sanity of those who might look at your code later on. when you're doing things like hooking up signals to slots, you can see we're referencing the screen grab widget or the screen grab, which is a Q button a Q push button that I dropped into the UI and named appropriately. And so when you're writing your code, it's easily human readable. You know that the screen grab button references the screen grab button that you built in Qt Designer, and you can connect up signals and slots as you see fit. And you can see I named it in Qt Designer, and that's the name that we ended up with in Python. Which leads us to, what do you do with the UI file that Qt Designer creates? You can see that there's a dialog.ui file right there in the resources folder within the bug reporter app. And there's also this build resources shell script. And what happens is when you run that, what it's going to do is it's going to take that dialog.ui file and it's going to pump out some Python from it in the UI subdirectory in the UI submodule that we talked about a little earlier. And what you end up with is a resources RCPY file, which contains compiled resources, things like icons that you might have added into your UI inside of Qt Designer. A dialog.py, which contains the layout as Python code, and an init.py that's required for you to import from this submodule. So once we have our UI layout built, we can start looking at how we're going to get this app up and running. And we're going to take a quick step back to look at the app.py. Like I mentioned earlier, this is the public interface subclassing from the application base class, but let's take a little look at some of the logic that we have here. The first thing we're doing is we're importing that app module that is bundled with the app. And the second thing that we're doing is we're building the menu callback and registering the command with Toolkit so that it shows up in the shotgun menu. And if we take a look at this import module call that we're making, you can see that we're importing it by name. And what that corresponds to is the app module underneath the Python folder that is bundled with the app. What you get back, that app payload that it's setting to, is a module reference, the same as if you had imported any other Python module. So you can treat it like a Python module that's been imported, as you always do. The second chunk of logic is building the menu callback and registering the command with Toolkit, with the Toolkit engine, so that it shows up in the shotgun menu. And what you can see is that we're using that app payload to access the dialog.py and calling the show dialog method that dialog.py is implementing. So let's move over to that dialog.py. This is broken up. I've broken it up into several sections. There's more code than I can fit on the screen at one time. So we're going to look at these things in a few different steps. First, we already talked about it, is we have to import the frameworks that import the components that we're going to be using from our Qt widgets framework, the screen grab and shotgun fields. And the second thing is this show dialog function that we called from the menu callback. And all that's going to do is take a reference to the instance of the app that was passed in. And from the engine property on that app, we're going to call show dialog, give it the name of the dialog, the title of the dialog that we're going to be opening, the instance of the app that's going to act as the parent for that dialog, and then the app dialog class that we want to be instantiated, which is the next thing that we're going to look at. We're going to break this down method by method. We have 4 methods that we're going to take a look at. The init is what you expect from any Python class. You'll notice that this is a Q widget. It's subclassing from Qt GUI.Q widgets, so there's nothing special about this. It's just straight ahead PySide code. And then we have 3 other methods, the get shotgun field, screen grab, and create ticket, that we'll take a look at, that are implementing some business logic for the app. So if we move to the init.py, this breaks down into a couple of different chunks of logic. And you can see that we're referencing self.ui. We're setting that to be the object that was built by the build resources shell script that we ran to convert the UI code that the Qt Designer application wrote out for us. That's instantiating the layout underneath it, and we call the setup UI method that the build resources script. injects into that dialog that we built in Qt Designer to basically build all of that stuff out. And then we can reference that UI property that we've created on ourselves. And in this case, we're going to connect up some signals to slots. We've got some accepted and rejected signals that we need to either create a ticket or close our dialog with, depending on whether the user hits OK or cancel. And then we have a button that we added to do the screen capture that we're going to connect to our screen grab method. And then, very importantly, is the shotgun field manager. This is something we need to take a step back and look at a little more closely in detail. And you'll notice that there's this initialize call and that we've connected an initialized signal to a slot here called get shotgun fields. And the reason we're having to do this is that the shotgun field manager needs to have access to the Shotgun database schema. And if that hasn't already been cached to disk, downloading that from Shotgun can take a visible amount of time. And what we don't want to do is we don't want to block the user interface while we're sitting there and waiting on Shotgun to give us the schema. And so what we do is when we call initialize, what it's going to do is in a background thread, it's going to grab the schema from Shotgun. And once it has it, it's going to initialize, it's going to emit a signal initialized that will then connect to and run some logic to get ourselves set up. This breaks down into a couple of places. We know at this point that we're ready to build this CC widget because the Shotgun Field Manager is ready to go. So what we're going to do first is we're going to get the CC setting from the app. If you remember when we looked at the info.yaml, we had defined a CC setting that provided that you could configure a comma-separated list of usernames, and that you wanted to act as the default list of CCs that show up when the user launches the app. So we're going to get that list of usernames, and we're going to query Shotgun. And you'll notice that from the instance of the app object, we have access to a Shotgun property, which is an authenticated Python API instance. So we can call find just like you would if you were using the Python API in any other way. And in this case, what we're going to do is we're going to get back a list of human user entities with login names that match one of the usernames that was in the list of usernames that were specified in the CC setting for the app. And we're going to get back the ID type and name fields, just because I know that's the important parts of the entity that we need to build this CC widget. And then what we're going to do is we're going to ask the Shotgun Field Manager to create us a widget. We're going to ask for a widget that represents the addressing CC field on a ticket type entity. And we're going to give it a parent. This is just a Qt parent of ourselves. So the widget we get back has a parent. And then what we're going to do is we're going to set the value of that CC widget to be the list of user entities that we got back when we queried Shotgun for the list of human user entities above. And we're going to add that widget to the CC layout that we built in Qt Designer so that it shows up in the user interface. And that's pretty much it. So we had to wait for the Shotgun Field Manager to download the schema from Shotgun. And then we were able to build our CC widget and add it to our user interface. Next up is screen grab. When the user hits the button to take a screen capture, we need to trigger some logic. And you'll see that it's all of 3 lines of code. One of the really cool things about this screen grabber is it really is a single line of code to get back a pix map after the user has dragged out a window that they want to take a screen capture from. So from the screen grab module reference that we got by import framework, there's a screen grabber class there and a static method on top of that where we can call screen capture, which will give the user the ability to drag out the space that they want to screen cap. We get back a qpixmap object that we're going to keep a reference to, because later on when we create the ticket in Shotgun, we need to write that out as a PNG file and upload that to Shotgun and attach it to the ticket that we created. And then I also had created a little preview window, a 100 by 100 Q label that will set the pixmap from the screenshot so that the user sees their little screenshot in 100 by 100 pixels, which is of dubious usefulness, but it's just a good example of what you can do with this. And this is a good place actually to take a break from looking at code and look at the development process itself, actually implementing this logic and getting feedback on whether it's working or not as you're going. And if you notice, if we launch the bug reporter and we take a screenshot and we haven't hooked up the signals and slots yet, that button doesn't do anything. So what we can then do is we can go in and actually, connect that signal emitted by the button to the slot to do the screen grab after I get through all of my typos. Once we've connected up our slot to that button signal, we can immediately go back into Maya, call reload and restart from the shotgun context menu, relaunch the app, and it'll work. It'll reflect the change in the code that we made. And that's a really important workflow because it means you don't have to close and reopen Maya or Nuke or whatever it happens to be that you're working in over and over as you're making code changes. You can iterate on your code very quickly and immediately get feedback inside of an existing session of Maya that you have open, and it'll speed you up a great deal. So if you didn't know about reload and restart, that's something that I definitely encourage you to take a look at. It's also great for debugging, even if you're not writing a new app, but you're trying to figure out a bug in one of your existing apps, being able to tweak the code, change logging, change some exception handling, jump back in, reload and restart, and then immediately relaunch your app. You'll be able to iterate very, very quickly. And it's something that we on the Toolkit team use constantly when we're debugging and writing new apps. So I strongly encourage you to take a look at it if you haven't already. We have one last very important bit of logic to discuss, which is actually creating the ticket when the user hits the OK button after filling out information in the ticket submission form. And this, again, is not a ton of code. If we break it down into chunks, the first thing that we need to do is we need to create a ticket entity in Shotgun. And just like before, when we were querying the human users to include in the CC list, based on the CC setting for the app, we have access to the Shotgun property on the app, which gives us a fully authenticated Python API instance. In this case, we're going to call create. We're going to tell it we're going to create a ticket entity, and we're going to give it a dictionary of information, of data that we want set on that ticket entity when it's created. Now, the first bit is what project to link to. From the app, we have access to the context. From the context, we have access to the project entity. So that's an easy one to do. The title is just pulling the text from the widget we have in our layout, where the user fills out the subject for the ticket, or the title for the ticket. The description or the body of the ticket is, again, just pulling the plain text from our QPlainText widget that we added to the UI and Qt Designer. And the addressing CC references back to the CC widget that we got from the Shotgun Fields widget. And all we need to do is get the value from that, which will be a list of human user entities that we will pass up and will be linked to from the addressing CC field on the ticket that was created. Second bit of logic that we need to take care of is what to do with the screenshot. If we have a QPix map stored in the screenshot attribute on our widget, then we need to write it out as a PNG file. We can just get the path to a temp file on disk with a PNG extension. We can use Qt to open up a file handle to that path that the temp file library gave back to us. We can open it in write mode, and then we can save that QPix map as a PNG to that path. Once we've done that, from the Shotgun API instance that we have, we can upload it to the ticket entity we just created. We have the ID of that ticket in the result that was given back to us when we called the create method above. We give it the path and we tell it what field we want to upload that file to, in this case, the attachments field on the ticket entity. And then last, we just have a little bit of information we show the user to let them know that the ticket was created. That's the last of our code. That's it. That's the entire app. One thing that's worth mentioning is that you'll have noticed that there was no Maya specific logic in this app that we wrote. It's all completely generic. That means that the app can be used with any one of our integrations. Here I'm showing it being used, launched from Shotgun Desktop. You can also launch it via browser integration. You can use it in Houdini, Photoshop, Nuke, you name it. There's nothing DCC or environment specific about this app. So anything you configure it for, it'll fire up and it'll work the same way. That's one of the strengths of Toolkit. The DCC specific logic or the integration specific logic is bundled up in the engine, and the apps themselves can be completely generic. Some additional features. I mentioned that this probably wasn't a production ready tool. It's very, very simple, but it is a good starting place. If I were going to put this together to actually use in a studio that I was working for, I would probably gather more information about the DCC session. You know, were they working in Maya? What version of Maya were they working on? I'd probably collect some logging information. You know, Toolkit writes a ton of logs to disk, so you could grab that log file and attach it to the ticket the same way that we attached the screenshot that they took. Maybe allow for multiple screenshots. I only implemented one. There's no reason why it couldn't be any number of screenshots or even arbitrary files if the user wanted to attach their work file or a simple repro case in a small file that they wanted to attach so that the support team had something to work from immediately. That would be great. Setting things like priority or severity so that the user can tell you how important this is, whether it's work stopping or something that can be left on the back burner for slower times. And then if you're doing things like multiple screenshots and arbitrary file attachments, that might take some time to actually upload. So probably some progress bar feedback so that the user understands that work is being done and they won't panic and feel like the app is frozen up on them. And that's kind of it. Worth noting, as I mentioned before we get to Q&A, all of that code that we just went over, including more documentation, I had removed some comments to better fit stuff on screen. So if you take a look at the code that's in the SG Dev Day 2018 repo for this presentation, you'll see a good bit of documentation in there as well. So you can take a look at what we did here and tinker with it as your heart desires. And that leads us to questions, if anybody has any. Very happy to answer questions here or via email. You can always find us on the Shotgun Dev email list. That is it then. You guys feel good about that? All right, with that, I will hand it over to Rob for the third and final presentation.
All right, thanks, Jeff. Let's get my sharing set up. All right, hi everybody. This is the third section of our webinar, and this is Introduction to Forge. It's a little bit different. It's less about talking about how to do toolkit specific things and how to use a different API in order to kind of extend what Shotgun can do and what Toolkit can do. So I'm the product manager on the ecosystem team. I've been working on pipelines since 2002, long time. And this talk was originally given at SIGGRAPH by Josh Tomlinson. So I'm standing in for him right now, and hopefully I do justice because he did an awesome, awesome job at SIGGRAPH. So in the next little bit, I'm going to talk about what Forge is, what APIs Forge has, and what you can kind of do with that, and give an example of what a possible integration between Forge and Shotgun could look like, and give you some pointers on how to find more information. All of the code that I show and the resources, like Jeff and Manny have been talking about, are available online. Here's QR code, screenshot, and you will be able to kind of have access to all of these examples pretty easily, get them up and running. So what is Forge? In our space, Forge is not incredibly well known, but Forge is the series of cloud services that Autodesk has that are completely API driven, that kind of expose a lot of the logic behind the things that Autodesk does, all of the services around knowing how to build and create things in a way that you can integrate into your own applications. So there's a bunch of different APIs that Forge makes available. You've got to authenticate in order to connect to all of it. But then there's a data management API that is almost like a Google Docs style document store where you can actually have some very high frequency data that you're putting in, subscribe to notifications as the data changes. It's all hierarchical. If you need a place to kind of do data storage and you can use a cloud service, it's an interesting one to look at. There's an API for reality capture so that you can very quickly do some photogrammetry and build models out of 2D image sequences, movies that you upload. There's webhooks API in order to get notifications when all of the rest of these APIs have interesting events that happen. There's a lot of Autodesk cloud services, BIM 360, Fusion 360. This is actually the services that back a lot of the functionality of those products. Like we use this internally. So a lot of the functionality of those apps actually has been componentized and made available via an API. The two that we're going to be looking at right now are the model derivative API and the viewer. So the viewer is actually a completely embeddable 3D viewport that is WebGL based, so you can pop it into a browser, interact with it. It's designed to be extensible. And the model derivative API is a transcoding service for geometry. So you can take lots of different geometry formats and turn them into lots of other geometry formats. In the example that I'm going to talk about, there's just a hypothetical. What if we could actually take 3D geometry, publish it into Shotgun, and review it? It's something that we've been asked for a lot. It's not part of the default Shotgun feature set. So what would it take to implement something like that? If you were to try to do that on your own, there's a lot that you would have to do. And this is kind of just a little demo of how using Toolkit to accelerate app development and Shotgun integration and Forge for these kind of high-level services that are targeted to these kinds of use cases, you can actually get going pretty damn fast. So in this video, this is just the first half of it. How do you get geometry in? What if we can just go ahead and in our publisher, we have a hook to upload to Forge. So over here, I've got an OBJ, and I want to just upload it to the modeling task. There's a plugin that we wrote that the code is available online that goes ahead and takes that file and uploads it to Forge. The actual code to do the upload is really simple. Literally, you just go through the auth, you get an auth token for Forge, and this is the code. You do an HTTP put and feed the data up. And what you get back from that is going to be a URN that you can then say, hey, that model derivative service, I want to take that OBJ and translate it into a format that the viewer that we're about to go into will understand. That format is SVF. And over here, you can kind of see asking the Forge services in order to do that transcoding for you is, again, a pretty simple web request. Here's the Python code that does that. And between those two things, that's the publish plugin. We already have the rest of the infrastructure needed in the publish app to take that little bit of logic, understand the file that you've dragged in, upload that, transcode it with just this little bit of business logic implemented as a hook. So if we take that URN and on the published file that we create or on the asset, fill out a field with that information, then when we go to a asset detail page in Shotgun, we can actually create a new tab that's just a web view inside the detail page and use the data in that field to feed a model viewer. And over here, you can kind of see that I've got localhost in there as the host in the URL. If you were doing this, you could run that on a server. But what's going on there is just a really, really small bit of HTML and JavaScript code in order to embed the viewer from Forge and show it on a web page. So literally, that HTML file, what it does is it initializes the Autodesk viewer and feeds it the Forge URN that we now stored in Shotgun. So that's the viewer side, and with the publisher, we've kind of uploaded the data and kept track of all the information we need to hook it all together. What does that look like? So now if we actually go into Shotgun and click around, I've got that juggernaut. I've had that URN filled out on it, and I go to the detail page. Now I've got that model view. So if I click on the model view, now that server running on localhost is getting that HTML page and initializing the viewer, and here's the OBJ that we went ahead and uploaded to Forge. It's embedded inside Shotgun, and all of a sudden you can have your 3D geometry show up there, just like you do with all of the movie files and still images that we support by default. So it's kind of an awesome way to very quickly get this kind of functionality up and running. And we thought it would be something kind of interesting to show you guys because there's a lot of fun things that you can play around with. Like I mentioned before, the viewer is very configurable. So we have an example that we're taking a little bit further. We didn't want to show the code in this very quick presentation, but you can actually add your own buttons, add your own UI on top of the viewer, have that interact with the contents of the viewer. And here's kind of an example of if I wanted to go ahead and add a note, a Shotgun note about the 3D geometry that I'm looking at, what that could look like. And this was kind of a demo that we had gotten up and running. And there's actually some GitHub repos out there that take that idea even further. So here's a demo of actually doing a more full-fledged 3D markup system built on top of the same viewer. And these repos are available for you to look at and play with as well. See if embedding this kind of stuff and taking the information that's being gathered by this markup system and uploading it as notes and attachments to Shotgun actually helps implement a 3D review pipeline for you. So, the kinds of things that you can do in the viewer is actually embed your own postcard style geometry, anchor it to something in a model. There's full texturing, lighting system available. You can have different lighting setups, and all of that is kind of interactive. You can actually get into the scene and have interface level geometry that that's just part of the business logic that you're putting together. So it's pretty cool, and there's a lot of people doing some pretty fun things with it. So the documentation for Forge is available just at developer.autodesk.com. That is kind of the main set of APIs that Autodesk is making available. Forge.autodesk.com is a bunch of extra information about this that's available. The publisher, if you've never written a publisher hook before, we've got docs on the developer.shotgunsoftware.com about how to go through and what the structure of putting together a hook for publishing that can do this kind of thing, what that looks like. And that 3D markup example that I showed at the very end there is just a publicly available repo. And all the links for all of this and the code that I was showing is available if you just go to that QR code and see what's there. So this was a really quick kind of bird's eye view of what Forge is and some of the possibilities of what you could do with that. And we just wanted to have a chance to show you guys to see if it sparked some inspiration for what you could build. Thank you.
All right. I don't think we have any questions at the moment. You guys can still feel free to type them into the little Q&A box if you do have any questions. If not, I guess we're pretty much done. I added the link to the Dev Day GitHub repo into the chat if you guys need that. Like these guys mentioned, the code samples are there. There are PDFs of these slide decks that we've used throughout and links to all the documentation that was mentioned. So that's super useful. I'll also mention This is the playlist. I just added a link to the chat for these Dev Day replays. The first two are there. The third one will be there shortly. So if you guys want to refer back to anything, it will all be there. And I think that's it. I think that's all we've got. Thanks very much for going through these 3 weeks of webinars with us. For those of you who were here for all three, I do see some names that were. And we'll keep you posted on the Shotgun Dev. And if you're not familiar with the Shotgun Dev list, Shotgun-Dev Google group is our community Google group for technical users of Shotgun, and we'll announce things like webinars there. Do subscribe if you aren't already, and we'll keep you posted on the next webinars. Thanks. And thanks to Manny, Jeff, and Rob for their presentations.
All right. Thanks, everybody.
Thanks, everyone.
Thanks. See you.
Bye.